నిన్నటి ఎపిసోడ్లో స్టైకోమెట్రీ టాపిక్ గురించి నేర్చుకున్నాం కదా. మరి ఈనాటి కెమిస్ట్రీ క్లాస్లో గ్యాస్ ఎనాలిసిస్ టాపిక్ గురించి తెలుసుకుందాం. ఈ టాపిక్ గురించి కెమిస్ట్రీ బోధనలో విశేష అనుభవం ఉన్న త్రివిక్రమ్ గారు వివరిస్తారు. మరి ఆ వివరాలేంటో తెలుసుకుందామా?
Dear students, today we'll discuss gas analysis. Gas analysis, or we can also call this as idiometry. Idiometry, because idiometer is the apparatus we use for measuring the volumes of gases under certain conditions of pressure and temperature. So we call this as idiometry. But actually this is nothing but stoichiometry only, at a part of stoichiometry in which we deal with those reactions in which only gaseous substances, only or exclusively gaseous substances are involved. So that the entire measurement is only finding the volumes of the gases and gas mixes, so that from the measured volumes and the changes in volume occurred, we understand what happened in the reaction, and by finding the differences in volumes during the reaction and after the reaction and before reaction, we can understand to what extent the reaction completed, or to what extent the substance is reacted and consuming the other substances, etc. So in this gas analysis, we have to take up those reactions in which majority of substances at least are gases. Suppose an organic compound's combustion reaction we take, say methane. Methane is a gaseous compound, and when methane burnt in oxygen combustion reaction, we get carbon dioxide and water. Okay, water is a substance. It may be in liquid state when you find the observations, when we make the measurements at room temperature, but if at all at certain high temperatures when we consider, it may be in vapor state. But if you keep that aside, remaining methane, oxygen, carbon dioxide, majority of substances are gases only, even at room temperature. So we deal with such reactions in which maximum are like this, gases. And in this process of using these gaseous reactions to understand the stoichiometric work, we have to depend on certain principles, like gas principles related to volumes. So obviously Gay-Lussac's law and Avogadro's law, etc. are concerned here. So in all these measurements, there are certain principles to be followed and certain precautions are needed. Entire work is based on measurement of volumes of gases, and they change with conditions like pressure and temperature. So throughout the work, the conditions are to be maintained constant. Before the start of the reaction, or at the end of the reaction, or anywhere in between, when measurement is made for gas volumes, it should be under similar conditions of pressure and temperature only. So by applying such laws like Gay-Lussac's law, etc., we understand the ratio of volumes concerned are obviously in ratio of the moles of the substances. So the reactions information about stoichiometry can be understood from these volumes measured. So it is called gas analysis. And in this work, we need to use certain selective absorbents to understand how much of this gas present, how much of the other gas present, etc. For example, in this reaction, methane gas being burnt in oxygen gas producing carbon dioxide, etc. So in this process, there are some changes we find. For example, if you find methane gas combining with oxygen to produce carbon dioxide, at room temperature, if the measurements are made, at room temperature, we find methane in gaseous state, oxygen in gaseous state, carbon dioxide in gaseous state. Water is of course not. Therefore, in our measurements, water does not come into picture. So we must do the entire work related to methane, oxygen and carbon dioxide only. Suppose I took some volume, some 10 cc of this methane gas and burned in oxygen. No doubt, the equation says that for 10 cc the requirement of oxygen is 20 cc, but in any combustion process, oxygen content should be taken more than its requirement according to equation. Excess of oxygen, burning in excess of oxygen only is combustion process. Measurement of volume under similar conditions is concerned. So what we are doing is here, when methane is burnt in oxygen, carbon dioxide form and water form. Suppose this is being performed, our measurements are being made at room temperature, water will be in liquid state. When it is in liquid state, it will not be accounted for our measurement. So we ignore water. So while doing this work, we should only concentrate on the substances which are in gaseous state. And the use of selective absorbents we talked about. And what is the use of selective absorbents? Suppose here we took methane and burnt in oxygen. As I said before, oxygen we take more than what it is suggested by equation, because combustion is possible comfortably only in the presence of excessive amount of oxygen. Combustion definition itself is burning in excess amount of oxygen. But when you took excess amount of oxygen, after reaction completed, after entire methane is completely burnt, also you find some leftover unreacted oxygen. So that must be understood, how much is left over, how much is reacted. From that the analysis becomes convenient. So we use here certain selective absorbents. Suppose at the end of this reaction we can understand the mixture contains no doubt carbon dioxide and also water in liquid state. If it is in liquid state, it will not be accounted for gas volume, but along with that some unreacted oxygen may also be present. So in our analysis, the unreacted oxygen cannot be accounted, because in any stoichiometric work it is concerned only to the part reacted. So how to understand how much the unreacted oxygen left over, so how much is reacted, etc. For that we take the help of selective absorbents. Those are like this. Suppose you use some solution like potassium hydroxide. Because of basic character, it absorbs acidic substances like carbon dioxide. Then oxygen gas. It is also absorbed by certain substances like alkaline pyrogalol. This alkaline pyrogalol particularly for oxygen to absorb. So when we use such absorbent, we can understand how much in the mixture obtained. The mixture obtained containing 2 in gaseous state carbon dioxide and oxygen, and 1 in liquid state water. But that in liquid state is not coming in our measurement, so only the mixture of these two will be recorded by iodometer. Then what we do, we pass that mixture through one of these solutions. Suppose I pass it through potassium hydroxide. Then coming out gas is only O2, because carbon dioxide completely absorbed by potassium hydroxide. Similarly, if I pass through pyrogalol, oxygen will be absorbed by this, and coming out gas is only carbon dioxide. So in the reaction, say I started with 10 cc and some excess amount, I am going to take 100 cc. Then after the reaction, 100 cc of oxygen is not completely reacted. Out of that, some 20 cc according to this equation will be consumed and 80 cc left over. So at the end of the reaction, the mixture consisting of carbon dioxide and this unreacted 80 cc of oxygen. So to understand that, I pass that mixture through, suppose potassium hydroxide. Then the volume of carbon dioxide is there completely, they are absorbed by potassium hydroxide. So volume of carbon dioxide not appearing at the end of the reaction when passed through potassium hydroxide. So the volume coming out is total volume, what is that before the reaction, minus the volume of carbon dioxide. So the difference will tell us how much is carbon dioxide formed in that. Or suppose if we pass through pyrogalol, 80 cc of oxygen is absorbed by that, so we find a difference of 80 cc in the measurement, and we understand this much is oxygen left over, and we know how much we took, so the difference is reacted. In this way, to understand how much reacted, how much formed in volume measurements of gases, we can understand in this observation. So from these measured volumes of gases, we work mainly in this stoichiometric part. Therefore, this work on stoichiometry is called gas analysis or iodometer. And what are the uses of this method? In this method, certain analysis will be quite possible in which particularly the organic compounds like alkanes etc. are burned, and in this conversion reaction to understand the molecular formula of an unknown organic compound, to find the composition of an organic compound mixture etc. will be possible. And for this work, after being the measurements made, we need to use those measurements for our calculation. What type of calculations we do here? We have to use the volumes measurement and make use of the volume measurements to understand the mole ratio in which the compounds are reacting. So, the chemical balanced equations in terms of unknowns we frame ready and use these results based on volumes, and from that